Now we'll see the how to code the smart contract. A smart contract includes data and condition with set or get operations on data. It resembles the basic unit of encapsulation in object orientation, which is called as class. So whatever the contract you want to write, you must write like a class. Solidity is a high-level language used to write smart contracts in Ethereum. So here is the following code snippet shows the writing of contract using Solidity. The first step you are supposed to use is pragma. It is just like hash include in C programming. Pragma, Solidity, is the cap symbol which used to represent the version of the Solidity in which you are writing the program. Because version to version, the features will change and the way of writing the code will also change. Of course, the syntax and all is common, but new modifiers, uh, new things were added in the later version. So, in which version you are writing, that you are supposed to represent. So that is pragma. So this pragma will tell you which version of the Solidity you are using. So pragma Solidity cap 0.4.0 contract simple balance. So here these are the data types, which is unsigned integer my balance. So obviously balance will not be in negative, and the balance will be from 0 to something. So function set unsigned int balance, my balance is equal to my balance, and get function get constant means whatever the balance you are going to return is like a constant value returns unsigned int. This is the syntax. So function is the way of writing the function. There is no return type for this function. So you can write anything. You can write anything. There is no like in C programming you won't write any return type. Function, function name, and list of parameters. All these list of parameters can be separated by comma. And here function get constant returns unsigned int returns my balance. It's a very simple code. Okay? The simple set and get method. Where does the computational infrastructure exist in a node? So whenever you write the smart contract, where it will be executed? Where is the computational infrastructure? Where does the code execute? How to execute the code irrespective of underlying hardware? Already we have seen this in the diagram that we are going to use the Ethereum virtual machine. So this Ethereum virtual machine will help you to load the code, execute it, compile it, and run it. So Ethereum virtual machine converts the application code into bytecode. Whatever the code you have written here, you are supposed to this. So whenever you compile it, Ethereum virtual machine converts the application code into the bytecode. All the Solidity programs, just like how the C program that you will say with the .c, Java program that say with .java, in the same way, the Solidity program should also say with the .sol, solve. I hope by this time you come to know how the program to be written. It is very important, like how you use the import statement or how you use the hash include statement in the C and Java programming. The same way, this pragma will represent the type version of the Solidity that you are using. So many versions are there of the Solidity. You can choose whatever the version. And whenever you are developing in the deployment environment, there also you have to mention in the configuration script that which Solidity version you are going to use. Based on that, the development environment like truffle and all, it will pick up the automatically the related version compiler and it will compile the Solidity code or smart contract code. Now, it is very important. It is very important to understand the structure of Ethereum. The reason is whenever you write any contract, or whenever you are writing Solidity code, it is very important to understand the structure of Ethereum. The reason is, yesterday I told you There are two types of accounts available. One is externally owned accounts, another is contract accounts. So the state of the Bitcoin blockchain is defined in the UTXOs, which are called as unspent transaction outputs. But the Ethereum introduces the concept of account as part of the protocol. So what is this account? Account is an originator and target of a transaction. So a transaction directly updates the account balance. There are two types of accounts are there. One is externally owned accounts. These are controlled by the private key. It is essential to participate in the Ethereum network. Like for example, company. Yesterday we have seen one example in the previous lecture. Company is having an externally owned account. No one can operate that externally owned account. Only company can do. The reason is it is controlled by the private keys. Whenever public key infrastructure is used, public key and private keys will be generated and given to each user. Public key can be distributed out, whereas private key must be kept with the user. Only that the user will know private key. No one in the network will know the private key. So, since externally owned accounts are controlled by private keys, so they will be having full control over the smart contracts that are generated and running under their control. So whenever that smart contracts were destroyed, the leftover balance will be credited back to the externally owned accounts. Contract accounts, these are controlled by code and can be activated only by externally owned accounts. That means you cannot directly create a contract account. Instead, you must have an EOA, and this externally owned account can activate the contract account. It represents the smart contract. So whatever the smart contract that you write, once you create instance of that, automatically one address will be generated. That address is the address of the smart contract. And this address will be generated under some account. Every account has a coin base or coin balance. So externally owned account interact with the blockchain using the transaction. Ethereum blockchain consisting of three things like header, transaction, runner-up, block header. These are the three main things under the Ethereum block. Next, we'll move on to the Ethereum structure. The participant node can initiate the transaction for Ether transfer or to invoke the smart contract. Both acts require transaction fee, also called as gas. So here the resource, cryptocurrency resource that is going to be spent is called as gas. In case of Bitcoin, it is said to be mining process, and here this is said to be gas. So why it is said to be gas? For every type of transaction that you carry on in the Ethereum, for each transaction, some points will be allotted. So how these points will be allotted? This is based upon the density of your transaction. Density means how many read operations involved, how many write operations involved, how many verifications involved, like identity verification, signature verification, like that, how many complex structure involved, how much complex is the contract execution. So based on that, points will be allotted. Based on the points, the related related wise will be consumed from your account. So both acts require transaction fee. So this is also called as gas. So this is a fuel for the payment of the payment model for code execution. Transaction is initiated only if sufficient balance is maintained. Fees are paid in Ether. Lowest denomination is Y. So what is the lowest denomination in Ethereum? That is called Y. It's just like what is the lowest denomination in rupees is paisa, like that. So 1 Ether is equal to 10 power 18 Y or 1 e power 9 gigabytes. This is what the 1 Ether means. So miners earn gas points based on the ether transfer amount. Example, let A has sent B 100 ether, then miner may earn 21,000 gas points. This is the fixed. Okay, this is the fixed gas point. So to add blocks to the blockchain. So one gas point is equal to 4 gigabytes, or depending upon transaction. So what are the things involved in the transaction? Receipt of message, signature of the sender authorizing transaction, amount of way to transfer, and message to the contract, and computational steps allowed for transaction, and fee for computation. So these are all involved in the transaction. So here, if you look at this is the Ethereum transaction structure you want to look at. So this is what the address, for example. So I am placing on the chat box. You can also side by side. You can go through that. So here, this is the Etherscan, etherscan.io. This website consisting of the searching mechanism for searching about a transaction. Only thing is you should know the address of a person, or you should know the transaction hash, or you should know the block hash, or what is the token generated. These kind of things are required for searching about a block or a transaction in the Ethereum blockchain. So here all filters are there. Just you click addresses, tokens, name tag, labels, and all. So you can either you may place anything here as a transaction hash. So here this is a transaction hash. So this transaction hash is of SHA-256 hash value. This consisting of here status, success, and block. This is the block number, and it was generated around in 2018. Okay, and from whom it was generated? This is the address of the person who generated this transaction, and it was this particular transaction was executed on so and so contract. So token transferred. So how many tokens? What is the token transferred, and from which address to which address? This is the originator 0x657 is there. So here also 0x657 is there, and to this one. So what is the cost of ether here? 0 ether. Why you are calling it 0 ether? Only token has been passed, not the actual currency. So what is the transaction fee was held here? This is the transaction fee held for this particular. It is just like your internet banking and all. Whenever you do some transactions, for every transaction there will be some transaction fee like that. So ether price is this much. So this is what the block structure. See, this Ethereum Etherscan will be showing all the things related to the transaction. For example, if you want to know more about this Etherscan, so Etherscan will show you the details of the blockchain, which is available on the main network, okay, and also on the test network. So this test network may be the ring B, like that. Several test networks will be there, so you can launch on any test network. Okay, so Etherscan can show the transaction information which was generated either on the main network or test network. There is another method called local node. Okay. Local node. So what is this local node? Local node means that this is the Ethereum service that is running on the local system, that is on your computer. In order to develop the web application, either you may take the help of the test network or local node. You can bind to this either test network or local node to run your application. Usually, whatever the general development environment that you do in our computer is working on the local node only. But if you want to share with the other users over the internet, then you may use the test network. But main network is the production environment. When you put on the production environment, you cannot take it back. So whenever you put on the production environment, you will be assigned with a chain ID. Some chain ID will be assigned to you, or you may choose one chain ID which will not collide with other chain ID. So as you have seen in the Bodhi Linux, so whenever I run this GETH, here you look at chain ID is equal to 1. So which is called main network. Like that, whatever the main production, what are the main blockchain IDs are there, blockchains are there, which was developed by various organizations, which are currently under the production environment, under Ethereum. Okay, all those blockchains will be getting their own what you call chain IDs. So using those chain IDs, other people can connect. So this is the way it will be happening. Okay, like that, main network will be having a chain ID. The same way test network will also be having a chain network, but test network is especially used for testing your application, if whether it is successfully running or not. This will be under the test for around several months, and you will come to know what is the defects in your application, and based on that, you will try to revise, or you will try to modify the application, or you may do some changes in the smart contract. Then finally, once you feel that the environment is correct and running fine, then as we discussed in the last lecture, some economics will be there, some payment will you are supposed to do, purchase some licensing and put it onto the production environment. So next one is, if you don't want to use the test network or main network, you can create your own node, local node, and using that local node, you use a high configuration server, and there you create a local node, and using that node, you can launch the local server, and that local server IP address may be given to all the members in the your university or college. So with the local network, within the local network, they will be in a position to communicate with your local node, and whatever the transactions happening, all those transactions will be recorded into the block, and that block will be saved in that local node only. Where in case of test network, main network and all, one can download the entire blockchain onto their system. But here in the local node, they cannot do like that. They can only save the block and the entire blockchain in the local node. It is just like a central server. I hope by this time you got what are the different categories of deploying your system, that is application system. So this is Ethereum transaction structure, and let us see the block structure. So this is a simple example. You can see one block. So I'm placing the same thing again in the chat box. You can go through this. You can also side by side open it. This is the block. This is the height of the block, and when it was generated in 2017. Okay, transaction total 127 transactions are included in this block. Okay, how many transactions will be included in the Bitcoin block? So maximum 6 transactions. But here you look at 127 transactions included in the block. Okay? So 28 contract internal transactions are there in this block. So 28 contract internal transactions, okay, and 127 transactions. So it's a very huge block. Okay, so Ethereum can support a huge block. So it is mined by F2 pool. Okay, this is the F2 pool. This is the firm, I think so. Who are the miners for this? Who have mined it? Their address was placed here. In order to mine the block, so once the block is mined, they used to get 3 ethers. This is a standard. So 3 ethers plus the transaction fee was added. So 3.08468 like that. So this is a standard in Ethereum. Whenever a successful block was created and added to the blockchain, then the miner will get the 3 ethers plus transaction. So next one is the difficulty level. Difficulty level in mining the transaction. So mining the block. This is the difficulty. So this difficulty will vary from over the time. Okay? So this difficulty will vary over the time. As the difficulty increases, the solving of the puzzle, that is mining puzzle, will also will become complex. Next, total difficulty. This is the total difficulty, and this is the size of the block, and how many gas points used. So any transaction will be allotted with some gas points. So you may use how many gas points were how many gas points were used to create this block. This is 99.63. So gas limit is this one, and extra data and ether price. So this is what the block structure is. Okay, currently the value of one ether is $1,634, $0.52. So from yesterday it was increased plus 2.98%. This is the change was happened. This is a blog Ethereum website where you can see all the block information. So an Ethereum operation is like this. An Ethereum node is a computational system representing a business entity. So in which what are the things will be there? So especially as you have seen, transaction initiation, validation, mining, block creation, smart contract execution, and Ethereum virtualization. These are the things will be available in the Ethereum node, which is called full Ethereum node. As just now I told you, local node, you may create it as a full Ethereum node. If it is a private network, there is no need of that one mining and all. But in general, you can also create the full Ethereum node. If you say that your node is a full Ethereum node, it will be having the facility of transaction initiation, validation, mining, block creation, smart contract execution, and Ethereum virtual machine. All these things will be there in the full node. So deploying and invocation of the smart contract will be like this. You have to develop the smart contract and deploy on the Ethereum virtual machine. So EVM can hold any number of smart contracts. As you have seen previously in this block structure, you will be having here 28 contract internal transactions. So different an EVM can hold any number of smart contracts and can execute. And remember, whenever the mining process is happening, all these smart contracts will be executed on all miners systems. Okay, and if all miners got the same result, then they will go for consensus. That is, they will go for agreement that okay, this transaction, this particular smart contract has executed correctly, and validations have been properly done. This is the way the miners will come to an agreement. So this smart contract, in order to execute this smart contract, we all know that every smart contract after compilation will be getting an address. What is that address? It is called as smart contract address. In order to operate this smart contract address, you should hold an account. What is the account? Externally owned account. So this account transaction, so this transaction will trigger or invoke the execution of certain smart contract. So Ethereum operations, you must understand the Ethereum operations. The input needed for the execution will be taken from the payload field of the transaction. The results of the execution are stored in the receipt. Once the execution of the transaction is completed, the state of the smart contract will be updated. Whatever the variables are there, fields in the smart contract will be updated. It is just like an object orientation. If any function was executed, or if you call any function, and its function and its supporting related variables or any other thing will be updated automatically. So state, this is called as state information of the class or state information of the block. So state changes by transactions are stored in the blockchain. Blockchain maintain both state and receipt hashes. So that is the reason only we are able to see what are the transactions. You can click and see, you can click and view what are the transactions stored in the block. And you look at here, wherever you find this. So this transaction receipt was failed. This transaction receipt status was failed. We can see what are the failed transactions which are included in the block, which are the successful transactions. And who are the initiator and who are the recipient, and what is the ether values, what is the transaction fee for each transaction. All these things will be recorded in the block. So this is what the continuous recording. Blockchain maintains both state and receipt hashes. Transaction validation involves checking of timestamp, sufficient balance for paying fee, etc. The beauty of the Ethereum blockchain smart contracts is unless until you don't have the minimum balance in your externally owned account, the smart contract will not be executed. Assume that in order to execute the smart contract, some 10 gas points are required. One gas point is equal to 4 gigabytes. 10 gas points means 10 into 4, 40 gigabytes. Wait. So at least your account should have that many gigabytes. Otherwise, the contract will not execute. So that is what the beauty of the Ethereum. Minor nodes receive, verify, gather, and execute the transaction. Invoked smart contracts code will be executed by all miners. As just now I told you, the same contract will be executed by all miners. If all miners got the same result, then they will come to consensus. Validated transactions are gathered and broadcasted for block creation. So this is the procedure of creating the block in the Ethereum blockchain. And what are the mining incentives? You can also start the mining process because the Ethereum will use the proof of work. So what is the proof of work? So the condense mechanism used in the Ethereum is memory based on the rather process-based proof of work used in the Bitcoin. Every action in the Ethereum requires crypto fuel called gas. So for every action that you perform in the smart contract, some gas points will be allotted. For example, loading from memory. This is the fixed 20 gas points. So store into the memory 100 gas points. Transaction base fee 21,000 gas points. Contract creation 53,000 gas points. These are the fixed gas points that will be consumed whenever you do operation. So that is the reason you must construct the smart contract or develop the smart contract as simple as possible. So as simple as possible means here no complex looping, no complex structure should be included in the block smart contract program. If you have the contract code is too complex, so much gas point, so many gas points will be consumed. So again, ultimately, it will deplete your account balance. So this is what the main problem, the main consideration that you must focus in writing the smart contracts. So what are the mining incentives? So here transaction cannot be initiated if insufficient balance is there. As I told you just now, if balance is not there, then you cannot initiate the transaction. The leftover amount after paying the mining fee will be returned to the original account. So here gas limit, it is the amount of gas points available for a block to spend. So gas limit is equal to 1.0 milli-units. Ether transaction fee is 21,000. Yeah, proof of work can be done by miners only on the full node. As I told you, if it is a full node, then only they can do the mining process. So what is the proof of work means? Some transactions were generated. T1, T2, T3, like that some transactions were generated. Now these transactions has to be verified. So that these transactions will go to the multiple people and they have to verify those transactions and has to come to an agreement that okay, this particular transaction is successful. This is the correct value or valid transaction. In order to do that, what is the benefit if you do this particular work? The benefit is you will get some monetary benefit, maybe some ethers or something. So whenever there is a monetary benefit, everyone will rush to that. So whenever everyone will rush to that, obviously there will be a crowd in the system. Or you have to do some things like you will keep some requirements. You have to satisfy these requirements, then only you can enter it. Like that, whenever any transaction is verified, so they have to undergo a puzzle, which is called hash puzzle. And the property of this hash puzzle is difficult to solve, but easy to verify. So this is what the uh, main theme of the hash puzzle. Who will give this hash puzzle? Your blockchain framework will give the hash puzzle. This hash puzzle has to be solved by the miner. If the puzzle was solved, then the incentives will be given. It is just like uh, whenever whenever your kid came and asked you, child came and asked you, I want to go out and I want to play or I want to uh, uh, play games like that. So first question what you ask is, have you done your homework? So, so homework is a puzzle. Okay? So homework is the puzzle. So it is very difficult to solve. Homework is very difficult to solve, but you can easily verify whether they solved or not just by looking at the school diary. So just to go to the school diary and whether this work was done or not, just to verify, it's simple. But doing that work is very difficult. So the same thing here. If any miner want to add a block in the blockchain, the main thing that you need to consider is hash puzzle, which is difficult to solve but easy to verify. How this hash puzzle will be there? For example, as a miner, everyone knows the block hashes. So that, for example, the block 0, then block 1, and then block 2, then block 3, like that is there. Now, as a miner, you know the hash of miner, know the hash of B3. So, whenever the miner know the hash of the B3, the blockchain framework, what it will do is, it will generate a puzzle like this. H of hash of this hash may be SHA 256 of block 3 plus this is the concatenation, some random number will give you digest, that is message digest or hash value, digest or hash value. Now the blockchain framework BC framework will give the digest or hash to miners and ask to find out what is the random number used. So you got a hash value, for example. Let me take one hash value here, some hash value here. Assume that this is the hash value and SHA 256 of P3, or we can say this digest is this hash value, some hash value. This is the hash value. This hash value will be given to the miners. Now already miners know the hash of B3. Now what they have to identify? They have to identify this random number. So this random number is said to be nonce. Nonce is a random number. Okay. So in order to search this random number, they cannot use a straightforward approach. They have to use a vigorous approach for identifying the random number. If the random number was taken between 1 to 1 crore, then just to keep a for loop or divide the numbers 1 to 1 crore into half, like 50 lakhs and 50 lakhs. Then you can go for searching of it. If it is 100 crores, still it's okay. If it is 1000 crores, still okay. Our process can capable of doing it because many of our processors will be having 3.2 gigahertz processor. So 3.2 gigahertz processor means this is the frequency. F is equal to 1 by time. So obviously P is equal to 1 by F. So one instruction will be executed in 1 by 3.2 gigahertz. second. So this is the second. That is the faster rate of executing. So giga means you will go for 10 power something. So still you will be in a position to find out it in a small time, little time, even though if you have pick up a number. But if you are taken from a large number, large pool of random range, like 2 power, like 2 power 256. It's a very, very big range. It's very difficult to identify. Okay? So 2 power 256 is a very large space. Which number it was given, we don't know. So identifying this random number is a very, very, very difficult task. So for this, you require you not this conventional CPUs. CPUs cannot do this work. So for this, what you require? You require ASIC computer, or you can say application-specific instruction computer. They will do only the hash. They don't do CPUs are general purpose computers. You can do any other task. But ASIC computers will do only hashing wire. So like that, ASIC computers will be ASIC processors will be used for doing this operation. I think you got the idea of how the mining process and mining puzzles will be given. This is only one example. In some mining puzzle, they may ask you to identify the first 4 words. Only first 4 will be given, or first 5 will be given, and you need to identify a random number that will generate that can give you first 5. So this is the like that. There is a variation in the puzzles also. I am telling you a simple puzzle, which you can easily understand. I hope you got this uh, particular thing, because from the large pool of random range, if you are the random number is given, it is very difficult to identify. A very simple example is I am taking a pin, a small pin, and I am throwing into a room. Okay? So throwing into a room means it is, even though it is difficult, you can even go and search it and identify where the pin is. The same pin I have dropped in a big hall, but it will take time. But still, it will, even though it is take time, it will take time. It is, you can search it and identify where the pin is there after some time. So maybe some little time may be taken. If you divide that range into, for example, if I have thrown into the hall of 200 by 200 size, or maybe or 150 by 150 size, then what you can do is you can hire 3-4 members, and you can divide the area as by 50 by 50, 50 by 50 like that, and ask each and every person to search in that area, and you may also search in other areas. If anyone found that a pin, it's well and good. So this way also you can do it, which is called mining pools. So one person cannot do this entire work. So what they do is they will hire the miners, which are having some good configuration or good capacity. They will join with the main mining company, and whenever any block to be created, they will be assigned some range. In that range, they need to search for the random number. If the random number found, then the majority of the mining fee will be given to those people, and some mining fee will be deducted from that, and as a commission or something for the pool manager. So in this way, mining pools were maintained. So if you have the ASIC computer or ASIC system at your, if you are able to purchase this ASIC computer, you can also tie up with any of the miners, and you can also earn some money with the mining process. So this is the way how the proof of work hash puzzles and mining pools, mining process will go on. Any doubts so far? Okay. So like that, gas limit and gas spent. So for every smart contract that was generated, some gas limit was allotted. Then based upon the transactions that you perform, gas points will be spent. So winner of the mining puzzle will be given 3 ethers plus transaction fee. That is what we have seen in the block. So 3 ethers plus transaction fee. Miners will get the fee for executing smart contract transactions. There may be other miners worked to solve the puzzle. As I told you, I have hired 3-4 members and asked to solve this puzzle in their area. If they get, it's okay. Otherwise, their efforts will be wasted. So there may be other miners worked to solve the puzzle along with the miner. So they will also get some consolation. They will also get some consolation, even though they won't get the puzzle solved. Miners who solve the puzzle but don't win the block are called as ummers. So blocks created by ummers are called ummer blocks. Ummer blocks may be added to the side chain to the main blockchain, and ummers are also incentivized with some consolation gas points. They will also get some consolation gas points. With that, they can their cost benefit analysis of spending time can be achieved. I can say return on investment can be achieved. So this is what the related to the Ethereum blockchain. Then we'll move on to the smart contract. Before moving on to smart contract, what are the other blockchain platforms available? Let us see. So here, Ethereum is the blockchain that we are discussing, which was developed using Go and Python language. Hyperledger Sawtooth Lake is one more thing. Multi-chain, Hydra chain, Open chain, IBM Bluemix blockchain, Chain, IOTA. These are the various blockchain platforms available. Along with this one, for R3, Codra R3 is also there. Like so many blockchain platforms are there. So some work with the JavaScript, some work with Python, some work with Solidity, some with the C#, like Stratus. Stratus is a blockchain platform where you will write the smart contracts in the C#. So what is here? So here Solidity, that will go for introduction to the Solidity, a high-level language for coding a smart contract. It is an object-oriented, contract-oriented, statically typed, Turing complete, and a high-level language for coding the contract. This is what the behavior. This is what the properties of the Solidity language. It is designed to target the Ethereum virtual machine. The syntax of the Solidity will be looking similar to the JavaScript. And you can go to this website for the Solidity release. So it is actively maintained in the GitHub. So Solidity program can be written and executed using the web browser with IDE called as Remix. So visit this particular remix.ethereum.org for IDE. You can go to this. Developing the code. So you can open the browser and you can go to this remix.ethereum.org. So I have already placed in the comment box that remix.ethereum.org. You can also click it and you can open it. So it will give you an opt-out inversion. So just choose a accept. Next, it will show you what other things are there. So next, this is what the Ethereum Remix IDE environment is. I will tell you afterwards, once we will discuss the Solidity code, how to use this Remix IDE. So Remix support only compilation and testing, but the deployment and all you are supposed to do. Using some IDE environments like Scruple and all. So to include smart contracts in blockchain on the on one can go for the blockchain gateway services such as Infura and all. Once we write the blockchain smart contract, then we can go for looking at the Infura and all. So here, storage state.sol. So Solidity basic. The first and foremost thing that what you are supposed to do is you need to use the Pragma, Solidity, and version of the Solidity. You look at in the Remix IDE, you can use the contracts and you can use the contracts. Already some example contracts were placed here. Storage.sol, owner.sol, valid.sol like that. And this particular Solidity programs, you can open it and you can see here. These are the examples. You look at Pragma, Solidity, greater than or equal to 0.7.0, less than 0.9.0. That means whatever the programming features that you have used in this program are greater than or equal to the features that are available in 0.7.0 version and below 0.9.0 version. So this is the way you are supposed to use it. And one more thing is, now whatever the program you do, whatever the program you write in the Solidity, for all these things, you need to include this SPDX license identifier GPL-3.0. This is must to be included in the at the top of the Solidity code that you write in the Remix ID. Afterwards, Pragma Solidity, and this particular code, this particular line has to be by default plus there. These are the template examples, template code. From this, you can copy and paste your and start working on your code also. So you simply just copy this and create a new file here and copy and paste there, and you start working with the writing the full length code. This is the way you can start working on this. And this Pragma Solidity, there are several versions out there. So continuously new updates are coming, new requirements are coming, and based on that, new features are added and new version is going to be released. So this is the default workspace of the Remix IDE, and then you will be having the searching for the file. Then here, Solidity compiler. You click on this, you will be having Solidity compiler. Since you have used the version of 0.7.0 and greater than 0.7.0 and less than 9.0, so here list of Solidity compilers will be available. You have to choose which Solidity compiler you want to use. So starting from 0.1.1 to 0.8.15. So since you are using this points 0.7.0 to 0.9.0 in this range, so you are supposed to use a Solidity compiler which is less than 0.9.0. So you can use 0.8.7. This is the latest local version of the Solidity, or 0.8.15. So it was compiled. So this program was compiled because this is 0.8.15 version is supportable version for compiling this code. So in this compilation, you can also include auto compile. Means as you are typing, automatically compilation will happen and will show you if there any error are there side by side. So you can. It is always recommended to go for auto compile, so that as you are typing here, if I am writing something here, you int 256 test number. So automatically it is showing error. Look at this is the error. So what is the problem here? The problem here is I have given the variable name with some space. I have to give the underscore so that it will become the identifier name, or it will fall under the identifier rule. So this is the way. Whenever you enable this auto compile, it will help you as you are typing. If you have any error, no need to wait till the last, that is till compilation time. There itself will give you error. Next one is, once the compilation is over, then you will be having two things here: application binary interface and bytecode. So what is the bytecode? On Ethereum virtual machine, on EVM, whatever the contract you place, so what is the resultant code you will get? The bytecode. Even in Java programming also, whenever you compile a Java program, you will get a bytecode, that is .class file. The class file consisting of the bytecode. Then you run the bytecode to get the result. So in the same way, this smart contract after compilation, you will be having the application binary interface. So this is the application binary interface. What is the application binary interface? It's a copy, just I place here. This is the application binary interface. It will be looking like a JSON file. Okay. So what it will be consisting of? It consisting of what are the internal data types, what is the state mutability, okay, what are the other inputs. These are all represented in the application binary interface. While coming to the bytecode is totally, we all know that zeros and ones. So this is the bytecode. Look at this bytecode consisting of complete this one, like this is the object code and opcode. So this opcode is, this idea has been taken from Bitcoin. In Bitcoin also you will be having the Bitcoin script, which is in the opcode. But remembering this opcode and writing is difficult. So there is a high level language is there called Solidity. Once you compile it, this bytecode will be generated, and this bytecode will run on the JVM, or EVM, sorry, at Ethereum virtual machine. At the same time for the opcode. I hope you got the understanding of how the Solidity program will compile and what are the artifacts that will generate after compilation. Now the compilation process is over. Then you can choose which program to be compiled, and you can also publish this contract onto the IPFS platform, which is called as Interplanetary File System. So you can also publish onto the, one can also publish onto the IPS platform or SWAM platform, which are the peer-to-peer network platforms where you can publish. Now the compilation procedure is over. After compilation, you got this application binary interface and bytecode. Now we go for the deployment. So deployment and run. So this is the deployment and run. We all know that this will work on the JVM, EVM, Ethereum virtual machine. So here Remix virtual machine is launched in the London, and Remix virtual machine Berlin. You can choose whatever the virtual machine you want. Or if you are running a local node, you can also use local node. Or if you are having an injected Web3 provider like MetaMask, you can also use injected Web3 provider. Hard hat provider, this is also kind of a provider. Ganache provider, which is a Ganache local provider for running the smart contract. Foundry provider, Wallet Connect. So these are the various options are there. And external HTTP provider. This is the external HTTP provider with which we connect to this Infura, which is called a test network. So here we have seen the Infura test network. There is this. Okay. So to include smart contract in the blockchain, one has to use the blockchain gateway service, which is called Infura, HTTPS something. So whenever we create a project, Infura will generate an address. That address can be used in the external HTTP provider. So like that, various options are available. We have seen previously in Ethereum, there are three main networks are there. Main network only for production environment. Once deployed, okay, can't be rolled back. Once deployed, you cannot roll back. Okay, so we can ignore this in the current moment. So ring B, this test network ring B or some other thing, or you can also use the Infura services, and you can connect to the ring B test network and deploy your contract there. So it will give you wide variety of environments to operate. Next, since you are supposed to operate this smart contract, uh, so you are supposed to operate the smart contract. Obviously, what are the accounts you require? You need two accounts. One is externally owned account, another is smart contract account. So here, this Ethereum, this Remix IDE will provide you some toy externally owned accounts, toy accounts with some toy ethers. Around 10 accounts it will provide you, and with some toy ethers to work on. So 100 ethers. These are not the original ethers. These are the toy ethers that you can test your smart contract. Okay. So I'm choosing the first account, and this is the gas limit. This is the default gas limit. Whether you may consume this many gas limits or may not consume this many gas limits. But if you are consuming less than this, that much amount will be refunded to you. And this is the zero ways. You can choose how many ways you want to spend for this. So here, function storage. Then you can just deploy. If you deploy, so this is the deployment will happen. Once the deployment is over, you will be finding this is the deployed contract storage at this one. Copy this. Now this is a smart contract account. What is smart contract account? This is the smart contract account. Okay. Under my account, which is an externally owned account, under my account, this contract was deployed. So this smart contract is the smart contract account, and this account will become the externally owned account. This externally owned account, in order to execute this contract, whatever the gas points are there, the related gas point fee will be deducted from the externally owned account. Previously, you have seen here 100 ether. Now it was came up to 99.9999 something 874,335 ether. Because in order to deploy the smart contract based upon the variables that you use, based upon the size of the contract, some gas points will be fixed, and that gas points will be deducted from the main account, that is externally owned account. Okay. So here, whatever the account is active, from that account the transactions will happen. So for example, you look at I'm selecting the last account. After selecting the last account, now the toy ethers are 100. Now again I will go for deploy. So what will happen? Again, new instance of the contract will be is created, and you look at the you just should copy this and paste here. So this is 0x3643, and previous is 0xD9. So for every externally owned account, they can also have their own smart contract account. So you look at, I have selected the last account. Whenever you select the last account, so last account from toy ether, that was 100 ether, whatever the deployment fees is there, that was deducted. That is the reason, if the contract was designed with a complex structure, automatically that much gas points will be consumed, automatically that much amount will be deducted from the externally owned account. So it is very dangerous. If the smart contract is failed, smart contract is built with complex structure, automatically huge amount will be lost from the externally owned account. So in Ethereum, nothing will be done for free. Everything will be cost based, based upon the number of variables, load operations, read operations in the contract. Based on that, gas points will be fixed. Based on the gas points, this particular amount will be deducted from the thing. So this is the way how this particular contract instances will be created. You can also delete the instances. These are all toy instances, and just to test whether your contract is running perfectly or not. So this is what the overall view of the Remix IDE. After compilation, you can also see the compilation and run script. and you can also see the space for this. And here are some settings where you can use, where you can, as a developer, you can also set it. So at present, we don't require this. Almost with the default settings only we will work it. Next, if you want to add any plugin, you can go for adding of the plugin. At the beginner stages, no need of all plugins, because if you want to see gas explorer, that is how many gas points may consume or this kind of thing in future, or if you want to explore some, if you want to debug the transactions here, either you may use debugger here active, or you may also use this debug here. So here debug is there. So whatever the transaction was generated, if you want to debug this transaction, how it was generated and all, you can go for debugging and all. At the elementary stages, no need to go for all these things. First, you will try to learn the how we can use this, how can we use this workspace and create the blockchain, create the smart contracts. And you can also see the building info, what are the addresses generated, all the addresses are placed here. And artifacts, I told you, these are the artifacts. So message data, see whatever the code I have placed here, so the same code was there. So we use this particular code in the Web3 APIs to connect with this smart contract. So these artifacts are very, very important for us to work with the decentralized applications. Scripts, you can also write some deployment scripts. You can also write the testing scripts here. So this is the way this Remix IDE will help us in writing the Solidity code. Here, in the deployment. Then Remix compilation process will go on. Once the Remix compilation is completed, then these are the artifacts that were generated. What are the artifacts here? You can see here. These are the artifacts. Okay. What are these artifacts? How many categories are there? So these artifacts are like this. Application binary interface. Application binary interface is the interface schema for a transaction to invoke function on smart contract instance bytecode. So this ABI will be used at the application level. That is, whatever the web application you develop, in that web application, we will plug this ABI, and with that ABI instance, will pass the parameters to the smart contract. So ABI is very important in our web application development. In order to do that, Web3 will help us a lot. Next is contract bytecode. The bytecode that we have seen so here, this is the contract bytecode will be generated. Next is web deploy script. So here, deploy script deploy with Web3. So if you are using the Web3 package, then simply you copy this and paste it into your web application, wherever the JavaScript is used. So enclose this within the script language is called JavaScript, and keep here and close the JavaScript. Automatically when the page is loaded or page is run, then it will be loaded into the web application. Thereby, if the web application is compatible with the Web3, then directly the application will be in a position to connect with the smart contract. That is called web deploy script. Next is gas estimate. So how many gas points are required to complete this, to execute and run the smart contract. So provide gas estimate to deploy and invoke the function. Function hashes. Function hashes are like this. For each function in the program, whatever the function you write, for each function, one hash will be generated. This function will be sent on to the hash function, and hash value will be generated. Because in future, you should not be in a position to change it. The reason is we all know that anyone can execute the smart contract on their machine. So we have already seen this. If I have installed EVM, and if I am the miner, I can execute all smart contracts. If I try to change any function and try to execute, then it will give you compilation error. It will give you error. The reason is already it will only store the hash function of the hash value of the function. You cannot make any changes to the function. If you make any changes, automatically you cannot. It will become invalid. So that is what the hash values. There is function hashes. Next is instance bytecode. The bytecode of smart contract instance. What is smart contract instance here? So whenever you deploy this, whenever you compile this, whenever the compilation is done, then the instance, whatever is generated, that instance bytecode will be used. So this is what the instance bytecode. But in out of all these things, for decentralized application development, we mainly use this web deploy script. This web deploy script consisting of two parts. One is JSON script to web application to invoke smart contract, and a script for grammatically deploying smart contract from web application. Okay, we require these two. So remaining and all are not required for us. Much importance is not there for us for the decentralized application development. Out of all these artifacts, web deployment script will play a major role in connecting to the plugging to the web application via Web3.js libraries. So this is what the remix compilation process and the artifacts. I hope by this time you might have set up the virtual machine. Now you come to know what is Ethereum, how Ethereum functions, what is Solidity, what is the properties of Solidity, and then we have seen the structure of the remix ID, what are the different components available in that, and what are the different artifacts generated by remix ID whenever you write any Solidity smart contract code. In the next session, we'll start with the programming, and we'll write some programs in the remix IDE, and we'll try to test the programs, and we'll try to use the MetaMask and also local server to connect to the smart contracts. If time permits, we'll also see the